Hi and welcome to my tutorial. Basically in last tutorial I talked about a lot of I just introduced OpenGL API and I did a lot of talking, unfortunately, which might have been a bit boring to listen to without showing you any kind of visual aid and things like that. I did a lot of talking about OpenGL API, describing what OpenGL API, the specification, and how it works in a very basic sense. But today, and I said last time that I was going to actually go into talking about memory locations, allocation, manipulation, and getting results, which is what OpenGL API does, like any other process that happens in your computer. But today I decided to, instead of going in the direction of talking about memory allocation, manipulation, and results, I've decided to actually go step out of all of that a bit for a second and kind of move into talking about computer graphics theory, right? Now this is an important topic because when you understand how the computer graphics theory works, because after all that's what OpenGL API is based upon, it's going to help you actually make far more better and efficient and effective and and faster and programs that are going to be utilizing all of this knowledge and understanding to help you better create code that's going to be more efficient to getting your results, and of course understanding how to use OpenGL API and using OpenGL API. Now, so what I've decided to talk about today is I've decided to zoom out all the way out of that, down to that kind of mid-level of programming and dealing with our hardware, and kind of talk about the topic of frame buffers. Now, the frame buffer might seem like a kind of very strange thing to talk about at the beginning, but the reason I decided to talk about it is because the frame buffer is just one step backwards away from the final outputs. So we're kind of now looking from the outside in. We've zoomed all the way on the outside, and we've kind of started to look into how this whole process works. Hence why I've had to move into computer graphics theory, right? So basically what's going on is everything that we see on the screen, right? Everything we see on the screen, right? All the calculations that occur in OpenGL API, or rasterization, all the shaders that run, the fixed pipeline, the programmable pipeline, all that happens, right? After all that happens, the final and the most absolute thing that happens is that our frame buffer, or the default frame buffer for our screen, right, gets updated, simple information relating to pixels. Now each one of those locations might represent a pixel, right? Basically, in principle, it should be representing a pixel, right? A pixel is what we see on our screen. As you know, our screen is 2D, right? And the 2D, because obviously we haven't actually got a 3D screen, we haven't got a holographic image. Everything we're seeing is in 2D, right? What happens is, though, that when we create a 3D object in 2D, is we just make a 3D object appear 2D. But how that happens is, when we zoom in further into that, is that we're actually seeing, in the retrospect, all we're seeing is pixels, right? These pixels are, in memory location, the frame buffer, default frame buffer for our OpenGL API, and they get updated what those values are, and those values are represented by RGB, red, green, blue, so we're just coloring in those locations in our frame buffer, right, which is then being outputted on our screen, and to us, to our brains, to us, how we see the world, it makes sense. To a computer, it's still ones and zeros, right? In the end, it's all ones and zeros. Whether but we use obviously mathematical methods to make those ones and zeros make sense. Like a line. When we're drawing a line, obviously we're gonna, in order to update that to our screen and our pixels, we have to kind of update it in a linear fashion using linear equations and mathematical models. And if we're drawing a circle, it has to obviously follow, the circular formulas of a circle. So it looks like a circle, so that way we can sort of update the correct place in our frame buffer, so the correct pixel lights up and gives us the perception of our circle. Another thing to notice as well about that is that a frame buffer, our locations memory represent data are actually discrete values. We don't have, a computer can only hold so much, right? Has so much space per data cell, so you can only hold so much, right? So our representation can only be so precise, right? But it's enough anyway. Nevertheless, despite that, it might not. It sounds like some sort of deficiency. It's not. It's for us, it's enough, right? We can create enough to make. Surely you've seen 3D graphics in games and you know, videos and movies, and it looks quite phenomenal. So today, as I said, I've decided to actually, for the purpose of graphics, describing graphics theory, what happens, you know, at the sort of what's the point of all of this? You know, why OpenGL does what it does? You know, what's the point of all of this? You know, what happens at the end of all of it? You know, I've decided to talk about the frame buffer, which is what gets updated to our screen. So what we do is I'm going to be creating a small software renderer, right? You know, I've implemented my own little frame buffer, you know, which is going to be rendering to my terminal, right? Let me just put these out for a moment. Don't want to go too far ahead. So what I've implemented is a small little screen, like you can see it, we call it a little screen, which is represented by a frame buffer, and each memory location in that array is going to be representing each pixel. And so what I've done is created a small little So what I've done is created a little screen, a little simulation of a screen, which is 64 pixels in this case, just using the term pixels, high, 128 in width, right? And what we're going to be doing is we're going to be actually rendering to it. As you can see, I've actually also colored it black here, just so it has a, you know, so it kind of follows a convention of how general, you know, what we generally print to an OpenGL API, because after all, this is supposed to teach you what you're doing, you know, what's the point of what you're doing, all of that, those commands you're running, you know, what's going on, right? What's actually going on in the end, because this is the final thing that happens after all the calculations are done, after each pixel is created, right? Let me just put this to, so you can see it maybe a bit clearer. I'll make this yellow. Right, after all that's done, it's these locations, right? After all that's done, it's these locations that get updated. So this is our frame buffer. As I said, 0 represent that our pixels have nothing in them, right? We haven't actually updated anything in it. And when we do put a value in it, we can make it, we can put it as a 1, or we can put it as any value, anything that's other than 0. And we can color it something just to give it a bit more of a lively feel. Maybe I'll stick to black after all. Otherwise it looks like it's already colored in. So as I said, here's my little software implementation of our own little rasterizer and our own little frame buffer with pixels. And what we're going to be doing to it is going to be just playing around with it to kind of get an idea what's going on. So here I've drawn a line. Now we could have drawn this line, you know, using a mathematical formula, right? Because that's important. You have to keep it, what I just said there is very important. You have to keep it in mind on the words I'm using here, right? In reality, how everything gets sort of brought down to the frame buffer from, you know, your ideas of 3D models and things is obviously for using mathematical, you know, formulas, right? To kind of approximate our values, right, on the screen, right? Again, this is because this is 64, you know, by 128, you know, obviously for this, you know, it's going to not give you exactly direct, nice lines and things like that when we're using, you know, formulas, right? And what's happening is here, as it happens with OpenGL API, is that in the end, everything gets approximated, you know, to our pixels, so that the right pixels sort of get lit up, and then we have the image of a line. You know, if you zoom in, for example, on, you know, even what OpenGL creates, sometimes you can see a very blurry and very crooked line, right? You know, to some extent, you know, when the dimensions of that picture are of a certain type, smaller usually. The larger they are, it's a bit harder to see it for our eyes anyway. But even if you were to zoom in to the point where if it was a, you know, huge HD, high definition, you know, pixelated image, even if you would zoom into that, you would still see a point where the lines are not exactly straight, because, you know, it all comes down to we're dealing with discrete values after all. But we sort of, in the end, we approximate values that sort of look like correct lines and things. That's what's happening behind the screen. Now, of course, in OpenGL API though, the only difference is that, you know, we use mathematical equations and mathematical tools to make it appear as close as we can to kind of real world correct lines and things like that, right? So what we're going to do next is we're actually going to do that. We're actually going to draw a triangle to our screen, right? And we can use this example we already have here. I'm just going to keep drawing it as I am currently, just directly manipulating those data locations in our frame buffer, right? And just making those values appear to us like whatever we want to make it to appear, in this case a triangle. But we will also do it mathematically, right? So just going back to this again, this is what's happening. Again, keep in mind, this is very important to keep in mind. This is what's happening under the hood. We just let's make our triangle, what's that, 1, 2, 3, 4, 5. Let's make the base of it 5 and the height of it, just put this in. So at the moment, if you were to imagine the OpenGL API, I'm kind of working like the OpenGL API because my brain's indirectly telling what it wants to do, and the OpenGL API is doing it for you, right? Of course, you can still make mistakes, same as the OpenGL API, but that depends on how you look at the situation. So I'm just going to go across here, make this 1, 2, 3, 4. So we have 5 across. Make it all 1. So we're going to be going 5 across, which is probably not going to be enough. 1, 2, 3, 4, 5, 6. Make it 6. We'll do half a triangle. How about that? Half a triangle. Right, we're going to render half a triangle here. Okay. I mean, I could have done this with a loop, probably would have been much more quicker. Maybe I'll do it with a loop. Yeah. I need to add some more values here. No, I don't want you to watch me doing all this coding, which is not really necessary. K equals 0, plus plus. Alright, so what we want to do is we want to make the frame buffer at each one of those positions equal to 1. Our displaying our frame buffer, which we can call, doing the final output. This could be called, this part here, I guess we can call this the rasterizer, right? We can call this the rasterizer, down to the very basic sense. Despite that we're not doing any mathematical location, we're manipulating directly by hand. Okay, so we have K and L. Hang on, did I get this right? Yeah, I did get this right. Okay, so what we want to do is going to make this equal to 1. Right now we're drawing a square. We're going to change this around a bit. Right now it's going to be a square. So if I do this, wait, check here. Right now we're going to get a square. Right. Well, we can go with that as well for now. Just to draw a triangle is a bit more complicated with this for now. Maybe I'll make the actual height less because it looks wonky right now. Aspect ratio is not exactly right. Aspect ratio is, yeah, it's a bit better. So let's just imagine anyway, nevertheless, for the frame buffer here is that we've drawn to that location, but let's just say, using OpenGL API, right? And obviously mathematics, what we want to do is draw to another location. So we simply let's say it's going to be 64 height, 64 divided by 2 to make it in the middle somewhere, and width. So we have our frame buffers drawn our pixels and given us that image. Now we can further manipulate this image and create things like lines and things like that. If we follow the equation of a line, if we decide to actually follow the equation of a line, right? What's the equation for a line? We know it's mx plus b, right? Y equals mx plus b. So b for x here, and it'll be y minus b divided by m for our x, right? We can use that as a formula to draw it to the screen right, for some values of x and y, right? Anything really we can say for every second one. We can say for every I divided by 7, you know, every, I don't know, j divided by 20 plus 5. You know, so how that happens doesn't matter, right? And it's not even important. But the whole point of this lesson and the frame buffer that I wanted to get your attention towards is that in the end, that's the final thing that happens, right? After all the calculations that occur, in the end, all that happens in the frame buffer is that these pixels, according to, you know, obviously, you know, the calculations that we made using whatever methods and whatever ideas like matrices and vectors and things, you know, the pixels in this frame buffer, which is one continuous memory, you know, gets updated. Obviously, there's a lot more than what we're seeing here. I mean, we can even make this picture bigger. We can decide to make this, we can make it, although it'll be very difficult to actually see it. Let's just double 128 and 256. 256. We can make it bigger, which gives us more accuracy. So if it's going to be double, we're going to need to double my screen, right? Which might be still not big enough. Okay, I'll just see what it looks like anyway. Just make sure I didn't do anything here. Get rid of this. So the point was that, okay, it was too big. It was too big, so I couldn't fit in my screen, and then we had this funny situation. But this is also a good thing that shows you here is that actually, in the end, doesn't matter how you print it, right? In memory, this is all that's being held. Is, you know, for those pixels location is, you know, for example, the colors of those pixels. You know, you don't have to print it out in the direct way. I'm gonna probably make this. Actually, I can make this bigger. I just have to make my actual terminal smaller, much smaller. It's tiny, but nevertheless, now it's probably starting to look more like the actual pixels we're seeing, right, on screen. And obviously, we're gonna have to change this to represent our 127 and 257. 154 and 254. So there we are. We have some kind of, we're probably getting closer and closer to actual pixel size as we make the picture bigger, right? And then each one of those probably values is going to represent our pixels. And if we decide we want to move this around, obviously in OpenGL API, we'll be doing it by using matrices to actually transform our, you know, our vertices to some new position on screen, and then that later gets rasterized to our actual screen by, you know, various methods and tools. But finally, it ends up as a pixel in our frame buffer. So if we decide that we want to, you know, maybe we can draw two circles, two squares. All we do is, for example, all we do is just show we want to draw it, send our vertex information, and obviously OpenGL is going to simply just update the frame buffer for us, and then we're going to have one screen, one block, two blocks, and we can move those blocks around the screen, you know, using mathematical manipulation. Like we can say, you can give me plus 100, plus 100. So that's what's happening in the end in OpenGL, right? We move this there, then move that there, and we can add more and more and more and do whatever the hell we want to do. We can fill up the whole screen with pixels that represent data to us. So hopefully that's giving you a nice little introduction into the frame buffer. Of course, we're going to get down and down more into the various OpenGL API as well as the computer graphics theory, but it's good that you can see what's going on, you know, what's happening behind the hardware. Hopefully you've kind of got an idea of what's happening, you know, out there, what's actually happening with when you're giving vertices to your OpenGL API. As you know, as I've said, you give your vertex information, you know, your vertex information gets converted into screen coordinates after various processes, and then those screen coordinates just pretty much update like a frame buffer, as we've done directly, which is what we've done. The last thing we've done here, frame buffer was updated, you know, with some pixel information, which is the color, and obviously the frame buffer represents the pixels, and in that color we can change the color here as well. Actually, we can make it blue, for example. Let's make it a green. we've updated, you know, our, or we can make one blue, one green if we wanted, but anyway, and then that information gets updated to screen, and then we have our pixels lit up, and then those pixels represent lines. You know, we could have drawn a line from the bottom left corner all the way to the top right, you know, doing whatever the hell we want to do. But the point is that in the end, right, that's what it all comes down to, right? Pixel representations in your you know, memory locations, and then having those pixels light up certain colors, and then when those pixels appear on your screen, they appear due to mathematical, you know, formulas and things that we've done. They appear like lines and circles, and eventually, finally, when you put those things together, or triangles to be exact for OpenGL API, when you put all those triangles together, they appear like, you know, images that make sense to us. So anyway, hopefully you've had a bit more fun in this lesson compared to the last one, which is a lot more talking, a lot more theoretical but non-practical. Hopefully in this lesson you've seen how this works, and now you have an idea of exactly what happens in that last stage of our OpenGL API. It's a very interesting thing. So now you know what's happening in the end, and now you know how everything even comes on screen, you know, and what it looks like in the end, right? As I said, it's just pretty much a frame buffer with, you know, ones and zeros that represent pixels that represent colors, which then line up when they get drawn to the screen as, you know, pixels that are lined up, for example, as I've shown you in my example, and then those pixels look like squares and lines to us, which then obviously when you put that together, the squares and lines and triangles, they look like other kinds of images. We can make complicated images from them. So yeah, hopefully that's been an interesting lesson for you, very informative and educative. So stick around, and I'll be making more lessons. Obviously there's a lot to talk about, you know, this is going to take a while. Don't expect this to be a 10 lesson course. You know, this is going to be, I'm going to get into details and talk about various different parts of OpenGL API as well as computer graphics to help you understand what's happening and help you make your programs better. Thank you, and keep on watching, watchers.